Yeah, no, I have a curiosity that is not related to this seminar that was very good, but it's about your research. So what you are doing, because you are working on something new that is very challenging. So if you can also tell us what you are doing, not a seminar, but just very few things about what you are doing for research, for your research, in such a way that they have also in mind what is researching in GIS.
Of course. So the research group that I'm working in is a research group of the Austrian Institute of Technology. So I'm not working at a university myself. I'm in a non-university research institute. And we're doing more applied projects with a lot of industry partners or partners from government institutes. And the small group that I'm in is doing a lot of data analysis, specifically data of moving objects. So my job as the spatial data analyst is often to get a new data set and try to figure out how to make it work. And the tools that actually it's pretty formalized already, this figuring out what the data is. And there's even books about it, and there's even specific books for how to do it for movement data that you can read. And the term is exploratory data analysis. And it's really a very iterative process. It's not like this, first you do this, and then you do this, and then you definitely get those results. But it influences a lot of the different fields that you touch on when you work with data. So you start from the real world, you collect some data, you process it and clean it, and then you can look at it for the first time. And then you figure out, oh no, we messed something up in the data collection, then maybe you have to go back to the next step and do data processing again, and you probably do a couple of iterations until you get that part right. And then you probably need to do a couple of other iterations, data cleaning, filtering out some errors, handling some outliers. So you also do a bit more iterations with the data processing and cleaning before you can start with any of the statistical modeling or machine learning or whatever is the really fancy stuff that you want to do in the end and what gives you the paper. But you have to do all the exploration before, because otherwise you don't know what you're talking about. And many people who do machine learning on some data sets which they don't understand, they get not so good results, but they might still be able to publish because maybe
sometimes very funny results. Like
there's always some results.
That I saw was people looking at the relation between the objects in OpenStreetMap and the risk. And what they found is that the postal office are related to risks. And when I asked what is the reason, they said, we don't know. The data is selling that. Okay.
But do you have a theory why there's a correlation?
No. No way of understanding this.
Yeah, there is this great website, what it's called, where you can spurious correlations, right? It's basically what that is as well. So, also this visualization, I love it because as a human you see obviously very, very different patterns, but a statistician only looking at the summary statistics, they would all look the same. You wouldn't even see the dinosaur that pops up in the middle of the animation. So really, I don't trust anyone who publishes results without visualizing them. So we do exploratory analysis to suggest hypotheses. When you just get a new data set and try to find out what projects you can do with it, you have to assess your assumptions. Like we got a data set that was from Denmark, so we thought, okay, that will include data from Denmark. And what we ended up seeing is it also included the whole North Atlantic. So suddenly you don't have a one country-sized problem, you have a half the world-sized problem. It can also suggest you suitable tools for analysis. It can inform more data collection, because more data is always better, right? And in the context of movement data, there are some specific things that you probably don't have so much in other data. So you have not just spatial queries, you have spatial temporal queries. You might want to do things like finding similar trajectories, so other objects that move from A to B, maybe not on the exactly same path, but on a similar enough path. You want to do summarizations. Of course, everyone always does heat maps. It's okay as a start, but there are also more sophisticated ones that you can do, which are grid-based. And there's things like extracting events, like the most obvious one is where do the trips start and where do they go, or also where do people spend how much time, which activities might they be doing there, and all those things about events and places, and also about outliers like unusual happenings, objects of a certain type moving where they are usually not found. So if you do that with a single individual moving object, it's simple. You can do your Spacetime Cube. They are really cute, and you can rotate them so people like them. But if you have more than like 2 or 3 of those trajectories, it becomes a big, huge mess, and that's what my research is focusing on, how to make sense of this mess and how can you still find patterns in these hairballs. And this is a simple exploration that I did purely in PostGIS. So there was not much programming involved. There was some SQL and different functions that already exist to create this one. But I also have a few examples of how to do a bit more sophisticated summarizations of this kind of dataset, which you can mostly find on my blog and on the related GitHub repositories. And really what makes this movement data exciting and also so difficult to work with, and the reason why there is no standard tools that you can just use, because one could think, okay, everyone is interested in movement data, why isn't there already some standard tools and approaches for working with it? It's because there's so many different movement data sets. The spatial resolution can vary hugely. You can have trajectories from tracking people based on videos. There you have the position on centimeter accuracy. If you trace the heads of people in a video, you know very exactly where they are. If you track someone with GPS, you know at least to a couple of meters where they are. If you track someone with mobile phone record data, you know in about kilometer where they are. So this already requires you to have very different approaches of working with it. Then the spatial dimensions, most of the data sets are 2D, and we can deal with 2D in GIS mostly. But of course there's also data sets in 3D, from animal tracking like marine mammals, or also plane data from aircrafts would be in 3D, and we have very few tools in the GIS world which really can handle these true 3D trajectories. So that's another of the dimensions that we have to handle with. Then there is a huge difference in temporal resolution. Sometimes you have a position every second. Sometimes you have a position every couple of minutes. If you do some animal tracking, you might only have one position per day or even fewer. Then you need to interpolate to get more information out of it. Then the sampling interval, the time between the observation might be regular. That makes it easy. But I have never encountered a data set that has regular sampling intervals in real life. It's just a theoretical concept. In real life, it's always irregular. So you either have to, again, make it into a regular one to apply those algorithms that require that, or you have to develop algorithms that can deal with irregular sampling intervals. You also have a movement that is constrained. Like if you look at car movement, cars usually stay on the road. But you might also have movement from ships or from birds, which are not really constrained that much. They move much more freely and not along a graph. Then you have different movement models. What I'm referring to here is those movement data sets which are continuous tracking, like GPS, versus those movement data sets which are from check-ins, like if you have Foursquare or any of those other check-in based, or if you have Bluetooth beacons where you're tracking people, then you only know, okay, now that person was at this location and then they reappeared on that location. But in between you don't have any kind of information. Then you have different tracking systems. Of course, if you have GPS and people give you their GPS tracks, then they are collaborative. Collaborative can have the downside that people can give you fake information, so you might want to be able to detect that it's fake. Then there's also systems which are not collaborative, where you're, for example, if it's video-based, then the person does not have to collaborate. They are just passive. They are only being videoed, and you're tracking them without them maybe even knowing. And then there's the whole privacy issue. Like, obviously, if you're tracking humans, then there's always privacy issue. If you're tracking animals, there can be concerns. Like if it's an endangered species, you might not want to share the data because of poaching or other dangers to the individuals. And finally, there's data set size. So you might have tools that are good if you are tracking like your 20 elephants in a herd and you want to see what they're doing the whole year, that might work perfectly fine. But if you want to scale it up to tracking all the aircraft that are traveling in North America or in Europe, then that tool will not get you anywhere because you need different approaches. So that's the main reason why there is no right tool for that, no one right tool, and no one size fits all. And this is all the things that I'm currently experimenting with. Of course, QGIS we talked a lot about today, and this is by no means a complete list. I'm also doing a lot with pandas. I'm currently developing a Python library based on pandas, which is called Moving Pandas, which should make it more easy to interact with movement data in this environment. And there's also interactive notebooks that you can try out. They are developed for self-study. And for the really big data sets, we are looking into Spark and Hadoop and all these technologies of distributed computation and storage, together with GeoMesa for the visualization.
And are you using R for visualization maybe, or data cleaning?
No, I don't use R personally. I do everything in Python.
Okay.
So basically my R is called Pandas. Mostly because it integrates better with all the other tools. I know that R is awesome, but it's limited in data set size and it doesn't integrate so well into the other tools. I have a much easier time reading from PostGIS when I use Python than if I would be using R. And I just never really got into it, to be honest. So that's our traditional workflow that we used to have a lot of movement data and spatial context data. And then there is this exploratory step that I explained. Then you can finally do model building, application evaluating, tuning, until usually not you're happy, but the project ends. And then you have to publish.
Yes.
And if the data set size grows too large, you might not be happy at all, and you maybe don't even have something to publish. So that's why we introduced these new tools for distributed computation as well. Yeah, here's a couple of advantages and disadvantages of the different approaches. Like QGIS, we already saw, you have a lot of different rendering options. The rendering performance is quite okay to the lower million of features limit. It's easy to add spatial context because you can add background maps. There's lots of analysis tools. You don't need to know how to program. It's quite easy to install. And there's a big community, which is not the case with many of the other projects that we are working with. The downside is there's very limited support for time. We have the time manager and such, but particularly for movement data, there's almost no support. So this is the time manager can do for you. It can make pretty nice animations for exploring movement data. This is movement pandas that I mentioned. I have this notebook, so it's good for reproducible analysis. QGIS can do some reproducible stuff because all the analysis that you run through the toolbox, they're actually recorded in the history. And you can copy all those statements from the history and put them in your documentation. But it's not as nice, obviously, as having a notebook in Jupyter or as any other notebook technology. So we have this advantage. We also have the advantage that Pandas has very good time series support, because the original developers, they were from financial modeling. So they always had time series of some stock prices, and that's what they were developed it for. We also have good spatial support thanks to GeoPandas, and now I'm working on the movement support. But the downside is you need to know at least a bit of Python to work with it. The community is still rather small. The rendering capabilities are certainly fewer than in QGIS, because you don't have the whole desktop GIS to work with. And it's so far also pretty slow on big data sets. So I have this one example with bird migration analysis. You can find it all online, and you can look through all the data cleaning steps that I'm presenting here, and through all the visualization steps that are going on to explore how these birds travel between Scandinavia and Africa every year. Yeah, and we are now scaling it up, so you can put more computers in it to make it faster if you can afford them. The available tools already have very good spatial temporal indexing, so you have very fast access to the data. You also have good spatial support because they build on existing open source tools. They are based on GeoTools. And you have good support for OGC standards, which helps you to visualize the data in desktop GIS. I would always be skeptical of any of those solutions which don't allow you to get the data out anymore, and which lock you in. And if you look into GeoMesa or GeoWave or any of those open source tools, that's usually taken care of. The real problem is the steep learning curve, the even smaller community, and again, we have unfortunately no movement data support here. But we can handle billions of records of data, 10 million per day over multiple years. And this is a live, not sped up view of this data set, on the fly heat map rendering of those billions of data. Of course, not all rendered at the same time, but only showing 1 or 10 minutes. But in the background, it is accessing the 8 billion records database and displaying it for you for exploration. So there's a lot of possibilities, a lot still to do. What we are currently doing is building a statistical model. This is the data where we first thought it's only Denmark, and it ends up being the North Atlantic and Scandinavia and everything. And it's all the ships, and we are trying to build a model that describes how ships move from one place to another, how fast they move, which direction they are moving. And then we are trying to detect, for example, outliers. If there's a tanker suddenly appearing somewhere where tankers shouldn't be, then we want to be able to raise an alarm. And these are currently our processing times. So we put in a couple billion records, and out come a couple million results in something like 1.5 hours, from originally taking us the whole night. So before, if the project was lasting for like 2 or 3 weeks, we could probably do 14, 15, 16 runs with different parameters, and the project time would be over. Now we can finally do a couple more parameter runs and really try to get them right before running out of time. There's a lot of challenges. You probably know those V's if you have ever been to a big data presentation, because they're always the same. From my perspective, velocity and volume is pretty much two sides of the same coin. There we need really efficient trajectory indexing techniques. Also, there is validity or veracity, which basically comes down to data quality. How representative is the data? Is there any bias? Are you not tracking all the people in the same way, but do you have some bias towards a certain group that is overrepresented or underrepresented? A huge challenge still is how to visualize those huge data sets so that you can actually see what's going on. And of course, privacy, because tracking data is horribly hard to anonymize. Particularly if you want to anonymize it in a way that still keeps it usable in the end, because what's the point of anonymizing data if you cannot use it for anything afterwards anymore? because most of the approaches that are out there, they only make it possible to have one analysis, one specific analysis afterwards, because they require a lot of aggregation, or they introduce a lot of artificial noise to ensure the privacy of the individual. But at the same time, they turn the data worthless for most of the other analysis steps. Also, most of the existing exploratory data analysis tools, they don't have any built-in privacy tools. If you give them the data that contains the home and work locations of an individual, you will see them. So that's also on the to-do list of research. And yeah, there's definitely huge work to do. And if you want to do any projects in this direction, we also have paid internships. You can come to Vienna, join us for a while, maybe write a thesis, and yeah, get in touch. Thanks.
Okay, thank you. No more questions? No. Okay. There is one question, because I know he's working on moving data.
Yes.
Maybe I have a question on these floating card point data.
Floating card data?
Floating card data,
Mm-hmm.
yes. Concerning the reliability of these data, I know that the datasets come around with some accuracy, but I don't know if this accuracy is enough to confirm their accuracy, or if it's possible to do some kind of additional reliability test concerning their position inside the network of roads.
I guess the answer here is it depends, because not every floating car data set will be of equal quality. So depending on where you have it from, it might be more or less reliable. The datasets, the floating car datasets that we are publishing with, they are from a cooperation with a taxi fleet. So there it's in the interest of everyone to have accurate locations, because they want to pick up clients. So they try to be as accurate as possible. So at least no one is on purpose sending you wrong information. While if you have floating car data from systems like Waze, maybe people have an interest in spoofing their own location, but they still want to have the information from the other participants because they want to profit from knowing the traffic situation. But they want to hide their own and are therefore sending wrong information to the main system. So depending on what kind of floating car data you have, I would be more or less careful about how to interpret it. If you're just referring to the technical side of making the GPS positions a bit more accurate, you can use map matching methods to determine the most likely route on a road network. There are more or less sophisticated ones with hidden Markov models, which really find you not just the nearest road link, but the most plausible sequence of road links that fit to a sequence of GPS positions. So that would be a technical approach to reducing the noise from the GPS around. But it doesn't help for the spoofing or the voluntarily sending you wrong information.
Okay, thank you. So if there are no more questions, we can finish here. Thank you again.
Thank you.
It was really interesting, informative, so I believe that all students are happy. Are you?